just as you take my hand, just as you write my number down, just as the drinks arrive, just as they play your favorite song, as your bladder disappears. No one will wind up like a spring. Before you had too much, come back and focus again. The walls have been in shape. We got a Cheshire cat grin, all blurring into one. This place is on a mission. Before the night out, before the animal noises closer get cameras, before you come but between the notes, the beat goes round and round. The beat goes round and round. It really got me. I just pretended that I was a blown instrument. As I set up shotguns, come on and let it out. Come on and let it out. Come on and let it out. Come on and let it out.
Today I am going to present about total suspended solids from group 5. Total suspended solids refer to the materials which are to dissolve in water and non-filterable in nature. It is defined as residue upon evaporation of non-filterable sample on a filter paper. Suspended solids absorb heat from sunlight, which results to increase in water temperature and decrease in level of dissolved oxygen. Photosynthesis also decreases since less light entering the water. As levels of total suspended solids increase, a water body begins to lose its ability to support a diversity of aquatic life. The objective of this experiment is to determine the concentration of total suspended solids in a water sample. The apparatus used for this experiment is a vacuum filtration system, a glass microfiber filter disc, some disposable aluminium dishes, a 47mm glass microanalysis filter holder, a drying oven, a desiccator, an analytical balance, and distilled water. This is the general procedure of the experiment. Firstly, a glass fiber filter is weighed to obtain the initial weight of filter. Next, water sample is shaken vigorously in a flask and transferred to a graduated cylinder for 1000 milliliter. The vacuum is turned on and water sample is poured into the filter holder using the filter that is weighed earlier. The graduated cylinder and funnel is rinsed with distilled water for 3 times to ensure all suspended solids in the water sample is transferred into the filter. After the sample is pumped out of the funnel, the vacuum is turned on. Next, the filter paper is dried in the oven for 1 hour and let cooled in a desiccator to room temperature. The filter is then weighed and compared with the initial weight. So for the data calculation for the experiment, to find total suspended solids is the weight of filter including the residue minus the weight of filter weight in the initial of the experiments times by 1000 and divided by volume of the sample filtered. That's all for total suspended solid lab experiment. Thank you.
Hi, I'm Ahmad Faizal. Procedure of total suspended solid. First, preparation of the glass fiber filter dish. Insert the filter dish onto the base and clamp on funnel. While vacuum is applied, wash the dish with 3 successive 20 ml distilled water. Remove all traces of water by continuing to apply vacuum up to water has passed through. Remove funnel from base and place filter in the aluminium dish and dry in an oven at 100 Celsius to 105 Celsius for 1 hour. When needed, remove dish from the oven, desiccate and wait. Second step, select a sample volume, maximum of 200 ml. That will yield not more than 200 mg of total suspended solids. Third step, place the filter on the base and clamp on funnel and apply vacuum. Wet the filter with a small volume of distilled water to seal the filter against the base. Fourth step, shake the sample vigorously and quantitatively. Transfer 100 ml of sample to the filter using a large orifice, volumetric pipette. Remove all traces of water by continuing to apply vacuum after sample has passed through. Fifth step, rinse the pipette and funnel onto the filter with a small volume of distilled water. Remove all traces of water by continuing to apply vacuum after water has passed through. And the last step, carefully remove this filter from the base. Dry for at least 1 hour at 103 Celsius to 105 Celsius. Cool in a desiccator and wait. Thank you.
I'm Kugan. I will present for the data collection. The sets given to our group is dataset A, as per in the diagram here. This dataset A consists of the sample from the parameters of atmospheric pressure, dissolved oxygen, total dissolved solids, pH, temperature, conductivity and salinity as per given in the schedule. For the item A, alkalinity, so here is the data that been inputted. So from the volume of HCl at pH 4.5, we can say that is a 2.0 ml. So the alkalinity of water sample to pH 4.5 is 20. Item B, 20 BOD over 5. Is it necessary to add a HCl into the sample for BOD analysis? It is not necessary if the pH of the sample is out of the range of pH 0.6 to pH 8. In HCl will be added in the sample is alkaline or will be added in the sample if acidic until the pH of the sample reaches 70. Here is the table and the example of the calculation. Item number C is the total solids, and this is the sample calculation to get the average. This is the graph that we have been plotted based on the data that we receive and from the calculation. As a discussion, according to the table of the BOD of the undersample, it is classified as class number 3.
Alkalinity test. The alkalinity of water is measure of its capacity to neutralize acids. The alkalinity of natural waters is due primarily to the salts of the acids, although weak or strong bases may also contribute. The objectives of alkalinity test is to gain a knowledge of the methods used to measure pH and alkalinity. Second is to be able to calibrate pH meter. And third is to determine the alkalinity of a water sample and express it in terms of part per million of calcium carbonate. Tools and apparatus needed for the alkalinity test is pH meter, burette, a measuring cylinder, a beaker, magnetic stirrer, and a hot plate stirrer. Reagents needed for the test is hydrochloric acid and distilled water. Procedure for the alkalinity test. First, rinse the pH electrode in 150 ml beaker with distilled water. Then, transfer 100 ml of water sample into the beaker. Dip the pH electrode into the sample. Stir the sample with a magnetic stirrer. Be sure that the pH electrode tip near the beaker bottom without touching the rotating magnetic stirrer. Record the pH when constant reading is obtained. Add hydrochloric acid 0.02 molarity using burette in increments of 0.2 to 0.5 milliliter into the beaker. After each addition, mix the solution thoroughly but gently with the magnetic stirrer. Avoid splashing. Record the pH when a constant reading is observed. Continue adding titrant and measure pH until 4.0 is reached. Data obtained should be recorded in a suitable table.